This is lesson 5.6 or page 15 in your notes for complex and imaginary numbers. We've been talking so much about solving, how we're solving for solutions to our quadratic equations. And we've talked about when we're solving, another name for those answers is x-intercepts. And we said there's two ways that we've been looking at finding x-intercepts so far. One is algebraically, and the other way is graphically. In the algebraic category, we said that there is the way of factoring, there's the way of square roots, there's something called completing the square, which we have yet to learn, and then there's your quadratic formula, which you've seen before. Now, three of these methods here, these last three, square roots, complete the square, and quadratic formula, are going to need something called complex numbers. So we want to talk about them before we jump into those methods a little bit more. So to introduce complex numbers here, think about what we know in terms of square roots. We know that if we say square root of 25, we know that the answer is 5. If we have x squared equals 36, we know that we could square root both sides. And again, remember, if you take the square root, you have to insert a little plus minus. It would say x equals plus or minus 36. But what do you do when you have x squared equals negative 36? When you try to take the square root, and even if you put that little plus minus in front, you have x equals plus or minus the square root of negative 36. And so far, we've been taught that we cannot do a problem with a negative under the square root. So this is what complex numbers help us with. We came up with, in mathematics, a way to deal with numbers under the square root. And we said it this way. We said there's an I squared, so instead of an x squared, it's an I squared, and it's equal to a negative 1. And we just said that's a definition. We're going to let I be a special number where it's okay that I squared is negative 1, so that when we take the square root of both sides, we're going to get I equals the square root of negative 1. And we're going to allow that to be true. So we're creating a new rule for the game of mathematics. So whenever you see a negative under a square root, we're going to call it I, and then treat the rest of the problem as we normally would. So that when you see something like x equals plus or minus the square root of negative 36, we're going to say, oh, that negative is the same as having I, because it's the square root of negative 1. And then you have regular square root 36. And the regular square root of 36 is just 6. So we will have 6i, and of course there's that little plus minus that sat out here the whole time. So that allows us to finish the problem and allows us to get an answer for it. It's an imaginary answer because there is no real number that we know of, not that we can count in real life on our fingers or measure out on the floor, that when we square that number, we get a negative 36. It's not possible in real life, so we say imagine if. And if we imagine that there's a number that could do this, we're going to get a plus or minus 6i. What you need for your definitions then is you need to make sure that you have I equals the square root of negative 1. We're going to use that a lot today. And then the other one that you want to make sure you have is that you have this I squared equals negative 1. That's the other one. So these two definitions here, those are what an imaginary number is. It allows us to finish problems where you would have a negative under the square root. All right, so let's see how we use this. First of all, square roots. So something like square root negative 12. We want to write this out as negative 1 times 12, and we'll recognize that this piece here is a negative 1 under the square root. That's going to come out as an I. Then we have the 12 under the square root, and we know that 12 has to be broken up into, we'll leave the I out here, 12 has to be broken up into 4 times 3, which then comes out as a 2, and then we still have the I, and then the 3 stays behind in the square root. So that's an example of taking square root 12, and it turns into 2i root 3. Another example, negative 54. If we break this up into pieces, we'll have negative 1 times 54. 54 can be 9 times 6, and we will take out the negative 1, out from underneath that square root. He comes out as an I. The 9 gets to come out as a 3. And then the square root 6 has to stay behind. So we end up getting 3I root 6. And if you have a perfect square number, like square root of negative 36, we simply say, well, that's negative 1 times 36. 36 is 6, and the square root of negative 1, that's I. So we get 6I is our answer. Now, none of these need a plus or minus sign because, again, the original problem has the square root written in it. Okay, whenever the square root is actually written in ink, meaning it's printed on the paper for you, already set to go, you just do it straight all the way through. If you are inserting a square root, so like up here when we had x squared equals negative 36 and I went ahead and drew in that square root on both pieces, that's when you have to add the little plus or minus to those pieces there. So that's how we simplify numbers that have imaginary i's in them. Think back to some of the other numbers that we know. You remember that we talked about the real numbers before, and we broke that up into the rational and the irrational numbers. Remember, the irrationals were the ones that had no pattern to them. No repeating pattern, I should say. Decimals that went on and on and on forever, or square roots of non-perfect squares, or things like pi. Rationals were fractions, or decimals that had a pattern, so 0.23, 23, ... There's a repeating pattern there. Or decimals like 7.5. And then we had inside of that the integers, and integers were negative things like negative 100, negative 3, and then we had whole numbers. Can we see in there? Whole numbers had positive things like 5, 0, 2. Positive numbers. Imaginary numbers fit over here. Imaginary numbers are things like the 6i that we just saw, or 2i root 3, or negative 10i, or square root negative 9, because when you simplify that, that comes out to be 3i. So imaginary and reals live in two separate camps, but they both fall under this blanket of complex numbers. So a complex number has a real and an imaginary component. A real and an imaginary component. The real components we're going to go ahead and call a's, and the imaginary components we're going to call bi. So when you see a complex number, it will be written in the form a plus bi. A and b can be anything. They can be fractions, decimals, square roots, but a must come from this world of real numbers, and b in and of itself could be from that world, but because it's attached to the I, it has to come from the imaginary world. This is important for us when we write our answers. So when we simplify complex numbers, square root negative 18 equals 7. Simplify your square root of negative 18 first, so that's negative 1 times 18. 18 can be broken up into 9 times 2, and then plus 7. And then the negative 1 gets to come out. The 9 will get to come out. So we will have 3i, and then the root 2 stays behind, plus 7. Again, this one is attached with the I, so that's the imaginary part. And then the 7 is just a normal number, so he's our real part. To write this in the correct format, we will say 7 plus 3i root 2. Another one, square root of negative 121. This would simplify to be 11i minus 7. Reorder it so it's in the correct order. This is your real component, so he goes in front, negative 7, and then your imaginary part, positive 11i, comes in the back. Sometimes you simplify numbers, like let's say you have 22 minus 5, and your answer for this one comes out to be 17. There is no imaginary component. This is just the real component, the a. That's fine. It could also be written as 17 plus 0i, just to show that there is no imaginary component to it. Either answer is correct. Or sometimes you just have the square root of negative 16, for example, and you know that your answer is 4i. It's fine to write your answer like this, or it's okay to say there's 0 realness, or 0 real components, and 4i for the imaginary component. So sometimes you'll see numbers that have both pieces. Sometimes you'll see numbers with just one piece or the other, and you can rewrite them like this, and that's okay. We want to talk about how do you add, subtract, and multiply complex numbers. So first of all, we're looking at adding and subtracting. So when it says simplify each expression, it means that we want to combine like terms and then go ahead and write our answer in the a plus bi format. This is a complex number, a plus bi. Here's another one, a plus bi. What happens when we add or subtract these? First of all, please notice that this little symbol right here, the negative, means that we are taking the first number and subtracting the second number. This is not foiling. Common mistake. A lot of people want to FOIL these. We are not foiling. We are subtracting. Subtracting these numbers. So we need to distribute that negative. When we distribute that negative, we end up getting negative 4 plus 8i. And then the 3 plus 6i stays the same. And then we combine our like terms. So to combine like terms, I'm going to put the 3 and the negative 4 together, so I get negative 1. And then I'm going to put the 6i and the 8i together, so I get plus 14i. That is my answer in a plus bi format. Second example here. This is my a plus bi number. This is an example where there's the a, but there is no bi. It's plus 0i. That's okay. Same thing, we're still subtracting with this little symbol here. So distribute that, we get negative 3, negative 2i. So 7 minus 3 minus 2i. Combine like terms, so we get 4 minus 2i. Alright, that's adding and subtracting. Let's talk about multiplying. When we're multiplying, you'll see something like 3i times 8i, or you might see something like 6i plus 5i. That looks more like your traditional complex number, but these are complex numbers as well. Multiplying them together, there's no symbol, so we assume it's multiplication. When you multiply these, we get 24i squared. I times I is I squared. Now, this is super important. Think back to what we said in our definitions at the start of the notes. We said that I squared equals negative 1. That was our starting definition. So if I squared equals negative 1, we are going to substitute a negative 1 in place of that I squared. And so we have 24 instead of times I squared, we have 24 times negative 1, or we have negative 24. Interesting that we go from two complex numbers to a real number. Again, you could rewrite this number right here. You could rewrite it as negative 24 plus 0i, because it is still a complex number in that sense, but we go from having i's to no i's. The squared becomes a negative 1. Alright, what do we do when you have ones with these larger parentheses here? Well, the good news is that you just end up foiling them. You FOIL them the way you normally do. So for us, let's go ahead and put our FOIL lines in. 6 times 4 is 24. 6 times negative 3i is negative 18i. Negative 5i times 4 is negative 20i. Negative 5i times negative 3i is positive 15i squared. Please, 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 please. Notice that this is an I squared at the end. So many people are going to just go ahead and leave it as a normal I, but it is an I squared. So when we come down to our next line, we want to substitute for that I squared. I squared is a negative 1. So we have 15 times a negative 1 at the back. These two middle terms can come together, negative 18i minus 20i, negative 38i, and then we have positive 24 still at the beginning. So we really have 24 minus 38i minus 15 from this guy here. So we'll combine these like terms and we get 9 minus 38i. That is our simplified version for part B. All right, let's try another example like this. Same thing, we want a FOIL. So we'll say 3 times 2 is 6. 3 times negative 4i is negative 12i. Negative 7i times 2 is negative 14i. Negative 7i times negative 4i, positive 28i squared. Remember, we have the squared in there. Don't forget the little I squared. So we will substitute for him in our next line with a negative 1. So we have 28 times a negative 1. And we'll combine the middle terms. So we have negative 26i. 6 minus 26i minus 28. So we have negative 22 minus 26i as our simplified form. So now that you know how to deal with complex numbers, you know what they look like when you add or subtract them, you know what they look like when you multiply them, let's see how would we use this when we're solving. That's how we started off our lesson. We're always solving. We're trying to find those x-intercepts, and we needed to know a way to deal with negatives under the square roots. So solve each equation means find the x value or values when the equation or when the function is set equal to 0. In other words, x-intercepts. Now, our first method that we learned was factoring. We could factor, but there's no need to. Factoring works well when there's 3 terms. Right here we only have 2 terms, and notice that we only have an x squared term. We said that this method, or excuse me, that this type of problem should use the square roots method. That's the quickest one. So we want to isolate the x. We're going to move things over. Move that 48 over. So we get 3x equals negative, 3x squared equals negative 48. Divide by 3. And then we need to square root that x. So square root both sides. Don't forget you have a plus minus when you put in the square root. So we have x equals plus or minus the square root of negative 16, which is x equals plus or minus 4i. So this is really 2 answers. This is x equals positive 4i and x equals negative 4i. It is possible to write your answer as just 1 if you would like to put them together like this, but I need you to understand that they are 2 answers, a positive and a negative answer. One more example for us to see these pieces fit together. Same thing, we're trying to isolate the x or find the values of x which make the equation equal to 0. So we will move the pieces over. Negative 5x squared equals positive 150. Divide by negative 5. X squared equals negative 30. Take the square root of both sides. Slip in the plus minus. So we have x equals plus or minus square root of negative 30. X equals plus or minus I square root 30. Can we break up the 30? I can't think of anything that breaks up into the 30. So that's our answer. Or again, it's really 2 answers. It's x equals positive I root 30 and x equals negative I root 30. Congratulations! You have now done complex and imaginary numbers for solving quadratic equations.